Hello, geometry friends. Here's part 2 of topic 1. And it's just kind of like a little extension, a little side thing from what we talked about with equations of lines that were perpendicular. So we're looking at how to write the equation of a perpendicular bisector. Now, we've defined this term in the past, and we've used this term in our proofs in different parts of our geometry curriculum. But now we're going to look at, on the coordinate plane, how do you write the equation of a line that is the perpendicular bisector of a segment? So a couple things. A segment can be measured. A segment is just a portion of a line. So a segment can be measured, so a segment can be bisected. That means cut into half, cut into two equal sections. In order to do that, we need to use the midpoint of the segment, because if a segment gets bisected, then the midpoint is like kind of the point of interest there. And then, of course, if we're talking about perpendicular lines, then we need to use perpendicular slopes to write the equation of a line that's a perpendicular bisector of a segment. So I have here the goal of this question: what is the equation of a perpendicular bisector of the segment that has the endpoints A at -4, +8, and B at 6, 2. So let's start by just graphing this and just seeing what this segment looks like. So now that I have this segment graphed on my coordinate plane here, I got to find two things that are kind of important about this segment. So for one, if I want to bisect the segment, I need to figure out where is the midpoint, where is the middle of the points A and B. And I'll share with you what is known as the midpoint equation. Like there's a formula to find a midpoint, but then there's also just a much simpler way. So let me show you both of these things. So the midpoint formula looks like this. So the midpoint formula goes like this. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Because after all, a midpoint is like the average of the x's and the average of the y's. So you add the two numbers together and divide by 2. So if I was to say that -4, this point is x1, and +8 is y1. So there's the first x and the first y, first x, first y. Second x, second y. I add the two x's together, divide that by 2. Add the two y's together, divide that by 2. You get the midpoint. Now, the midpoint formula works, always will, always has, but there's kind of an easier way when you're looking at a graph, and let me show you what that would look like. So the other way that I can find the midpoint of two endpoints is I can just count. To get from point A to point B, I had to go down 6 units and to the right 10 units. Midpoint means middle, or half of that. So if I go down 3 and right 5, right there, that point is the 0.15. That point must be the midpoint. Okay, so let me summarize what we just did right here, and then we can move on to step 2. So now I'm like halfway there. I know that my perpendicular bisector must go through this point. It has the coordinates 1, 5. So I know what point my bisector has to go through. I just don't know one other characteristic about it that describes that line, because that line can basically be any form that goes through this point. Any line that goes through this point could be a line that would go there, but I have to make sure that it's not just any line. It has to be perpendicular to the line AB. So step 2 is to determine the slope of the line from A to B. So step 2, determine the slope of the segment AB. Now you can do this two different ways. You can either look at slope as the rise over the run, or you can use the equation, the slope formula, which is basically, again, if we look back at what this is, x1, y1, x2, y2, it's the difference of the y's divided by the difference of the x's. So, but I think a much easier way is counting, because we already did this part. To get from point A to point B, we have to go down 6 and to the right 10. So over here I wrote the slope with a subscript. That's kind of like the font is a little smaller, and kind of down at the bottom right here, the slope of AB is -6/10, which you could also call -3/5 if you're going to reduce that fraction. So that's step 2. Step 1, I know the midpoint. Step 2, I'm going to determine the slope of my line. Why do I need to know the slope of the given line? Because I want a line perpendicular to that line, and perpendicular lines have negative reciprocal slopes. So that's step 3. Determine the slope of a perpendicular line. So step 3, determine the slope of a line perpendicular to the segment. Remember, perpendicular lines have negative reciprocal slopes. So the slope from A to B was -3/5. The slope of a line perpendicular, so there's M for slope. The perpendicular symbol, the slope of a perpendicular is a positive 5/3. So now it's time to just kind of like put this stuff together. Here's the slope that I need to use for a line that's perpendicular. And here is the point that my line must go through. I have to make sure that I go through the midpoint of this segment, and it has to be perpendicular to the segment. So I have a point, I have a slope. The most appropriate way, or the easiest way for me to write the equation of this line, is to use a point slope form. So let me go ahead and do that. So the equation of my line in point slope form is y minus 5, because 5 is the y coordinate of the midpoint, is equal to the perpendicular slope times parentheses x minus 1, the x coordinate of the midpoint. So there's the answer to the equation of a line that is the perpendicular bisector of the segment from point A to B.